Understanding ESX. Before we can talk about any of the enterprise class features or do anything with ESX, we have to understand the architecture. Especially considering ESX comes in two different editions. You have ESX and then you have ESXi. So before you can install either version, we have to understand the differences. But in both cases, ESX and ESXi are both bare metal hypervisors, which means the actual ESX software gets installed on bare metal. There is nothing between the ESX software and the actual hardware. Now, by installing the ESX software, whether it's ESX or ESXi, you create a virtualization layer, otherwise known as the VM kernel, otherwise known as the hypervisor. Now, it is this hypervisor that sits between the physical hardware and the virtual machines that sits on top. And you can think of the hypervisor as the maestro. It is the coordinator. It is what regulates the virtual hardware's access to physical hardware. Now think about it this way. If you didn't have a hypervisor and you had 20, 30, or 40 virtual machines running on this physical hardware and they're all trying to access the physical hardware at the same time, it would be a mess because there would be no scheduling. They're all trying to access it at the same time. So the hypervisor's role is to regulate the virtual hardware's access to the physical hardware. At the same time, its responsibility is to make sure that this virtual hardware gets to the physical hardware as quickly and as efficiently as possible in order to give these virtual machines the best possible performance. Now you'll notice here in our graph that we have the service console. So what is the service console? You can think of the service console as the first virtual machine that gets installed when you install ESX. And the reason for the service console to exist to aid the VM kernel in loading. It is this service console that is a 64-bit operating system. It is based on a Linux kernel version 2.6, which is equivalent to a Red Hat Enterprise 5.2 or CentOS 5.2. Now, there's a lot of confusion here because a lot of people think that VMware's ESX is based on Linux or on an iteration of Linux or Unix. That is completely false, and be careful if you're taking the VCP exam because I can almost assure you that's going to be one of the exam questions. The VM kernel is a VMware proprietary kernel. It is not based off of Red Hat or Unix for that matter or Linux. The service console, however, is based on an iteration of Linux. The service console is there to aid the VM kernel in the boot process, and it also gives the VM kernel access to extra applications like features. So it extends the VM kernel, but the VM kernel itself is not based on Linux. So we'll take a look at that in the next slide here. So you'll notice here that the VMware service console is the management interface for the VM kernel. So it is how you control and manipulate the VM kernel. You do that via the service console. Now the service console extends the VM kernel by giving it a firewall, by giving it an Apache Tomcat web server, by giving it SNMP agents, shell access, SSH, etc., etc. Now let's talk about ESXi. What is ESXi and what's the difference between ESXi and ESX? ESXi is a much lighter version of ESX, and the difference for being so light is because it doesn't have a service console. ESXi is simply a 32 meg footprint, so it is extremely light. And the reason there is no service console is because a lot of complaints came in as to we want to install an antivirus in the service console. A lot of people were worried about what if there's a vulnerability that's found in the service console that can be exploited. So what VMware did is it completely removed the service console. It removed that surface of attack. So now there is no service console, so there is no way to get any kind of attack against something that doesn't exist. That's the purpose of ESXi. And the roadmap for VMware, for those of you that want to know, is ESXi all the way. So the next version of ESX that gets released, whether that's vSphere 5 or if they change the name, there will not be, or at least as of this recording, we are told that there will not be a version of ESX. So the version of ESX that has the service console installed will not exist anymore, and the roadmap for VMware is that they're going to continue to enhance and build into ESXi. Now the reason you would want to go with ESX versus ESXi is that with ESX you have the ability to create and configure certain scripts that can run within the service console. With ESXi you have no access to the service console. It doesn't exist. Everything is controlled via the vSphere client and through Virtual Center. So you can't log in through a command line unless you are using the VMware command line virtual appliance. Then that gives you command line access to ESXi. Now ESXi is available in two different formats. It's available either in an installable format where you get an ISO or a CD or whatever the case might be and you install it manually, or a lot of manufacturers today will sell you a server that has an embedded chip with ESXi. So you bring the server in, you rack it, you power it. As soon as it comes up, voila, you have ESXi that is completely running. You can start to install your virtual machines immediately, attach it to Virtual Center, extend its features to enterprise features. Now, let's open a bracket here. ESXi is free, just like they say Hyper-V is free. But with ESXi alone, just like with Hyper-V alone, you can have access to any of the enterprise class features. So for those of you that are wondering, there is no difference between ESXi and ESX. Whatever you can do with ESX, you can do with ESXi. Because a lot of people think that, oh, we're getting ESXi, that's the free version. That's incorrect. ESXi needs access to Virtual Center in order for Virtual Center to extend its features into the enterprise to get access to vMotion and storage vMotion and cloning and so on and so forth. But you can download ESXi for free, install it on a server, and have the ability to load virtual machines. You just can't have enterprise class features. So if you're trying to wonder which version to install, ESX or ESXi, and you don't have a prerequisite for certain software or certain third-party tools that need ESX, or if you don't need to have any sorts of scripts that run in ESX if you're upgrading from an earlier version, then I say for sure go with ESXi, because that will make your upgrade down the line much easier, considering VMware is not going to continue to develop ESX. Now, before you buy any sort of hardware for your vSphere deployment, I strongly recommend and stress that you should check with a VMware compatibility guide. And I've provided some links here for you on screen as to where you can go on the VMware website to get documentation for vSphere 4 and to check the compatibility guides. Now granted, if you call someone like a CDW, or if you're going through a reseller, or if you're going through HP or Dell or IBM or Cisco or, as soon as you tell them what you're going to use the server for, what the function of the server, what type of operating system you anticipate to install on this server, they're going to give you, or they're going to help you configure hardware that is compatible with the operating system that you're trying to install. So if you tell them I want to use this for VMware, then they're going to tell you if there are certain components within the server that are not compatible with ESX. However, I still strongly recommend that you check the compatibility guide just to make sure that the hardware you're purchasing is compatible. The last thing you want to do is have those servers come in and those parts come in and they're not on the compatibility list and they don't work properly. So granted, most of the vendors today have automated systems and automated matrices that tell you what's compatible and what's not. I would still recommend you check with a compatibility guide, especially if you're trying to buy components like from a CDW off the shelf that you want to, you're buying an HBA card or an iSCSI hardware initiator. In that case, again, the compatibility guide will come in handy. Now in this slide, these are some of the hardware, server hardware that can work with ESX. Now, there's so many hardware today that can work with ESX, we can't list them all, but I'm going to go through some of the Dell and HP comparisons of what you can use as far as hardware manufacturers. Obviously, you have the 1U HP ProLiant DL360 and its equivalent on the Dell side, the PowerEdge 1950. Now, again, these might have changed a little bit from Dell's perspective. These numbers might not be 1950, it might be 1970, but it's the 1900 series. This is a small server and it has limitation as far as the PCI slots. So this might be a good fit, for very, very small environments, but anytime you get into the mid or enterprise class environments, you probably want to try to avoid the pizza boxes as much as possible. The DL380, which is the next bullet point here, which is equivalent to the 2950s and the 2970s, and those numbers might have changed as well. The 2950s are the Intels and the 2970s are the AMDs. The 380 is a very good box. The HP ProLiant 380 is a great box. It's a 2U box. It's decent for mid to enterprise size organizations that are trying to do virtualization. But by far, in my opinion, the best box for ESX and for virtualization would be the HP ProLiant DL580 and its equivalent on the Dell, which is the PowerEdge 6800 series or 6900 series. Now, IBM has good servers. Cisco has great Cisco blades these days. And let's talk about blades. So you have the PowerEdge blades and then you have the HP blades. the IBM blades, you have the Cisco blades, the Hitachi blades. Hitachi blades are great, by the way. And let's open a bracket here. The nice thing about the Hitachi blades is it allows you to do virtualization at the hardware level. So some applications, you're always going to notice that there are certain applications that you cannot virtualize. You want to keep certain applications as physical boxes. Where with the Hitachi blades, what you can do is, let's say you have 8 blades in an enclosure. What you'll do is you'll take 4 of those blades, you put ESX on them, and you do your server consolidation and your server containment project on those. And then for those servers that you don't want to virtualize, what the Hitachi blades allow you to do is you can take each individual physical blade and partition that blade into logical servers. So this never existed before now on the Intel platform or the x86 platform. But now you can take a single blade, partition that into up to 16 logical servers. So at that point you're virtualizing, except you're virtualizing at the hardware level. So those applications that you couldn't virtualize, or for whatever reason you're not comfortable virtualizing with ESX, you can virtualize them at the hardware level. So in one chassis you have virtualization at the hardware level and virtualization at the software level, which is fantastic. However, here's one thing that I want to open a bracket for here. In my opinion, there isn't an application today that you cannot virtualize. There should be no reason to not be able to virtualize an application unless it has specific requirements like a USB dongle or certain things on the back end that would prevent it. Otherwise, from an I/O perspective, we can handle every I/O that you can handle on a physical PC or a physical server, we can handle in a virtualized environment, up to the point where we can attach a PCI card directly into a virtual machine, if in the case of an HBA or a NIC, and give it all the I/O throughput that it needs. And that applies to blades as well. We've done many projects where we've deployed blades. The only thing I'm going to caution about blades is if you're deploying everything in one chassis, you have 8 blades and you're doing ESX across, you've just created a single point of failure. So just make sure you take that into account, and if you have multiple chassis for ESX, then that makes it a little bit easier, and make sure you build your clusters accordingly. Now a couple of more slides, I promise, and then we're going to get to the fun stuff and we're going to install ESX. But before we do that, we got to talk a little bit about partitioning. And why would we want to partition a drive? Now for several reasons. First of all, for performance, for stability, so that directories, important directories such as the root, for example, don't fill up, etc., etc. There's a lot of reasons, and also because the software that we're about to deploy requires partitioning of the disk. Now a lot of you might be Windows users that are not familiar with the Linux file system, such as myself. I don't consider myself a Linux expert by any means, but the Linux file system is not that difficult to understand, and I'm going to try to break it down for you. Now, why are we using the Linux file system? If we go back a little bit, I told you that the VM kernel doesn't have any function. It can't even boot up on its own. So it relies on the service console to provide functionality, administration, and an interface for it. And because of that, because the service console is based on Red Hat Linux, we are going to partition the disk based off of the Linux file system. So let's bring up a whiteboard and explain exactly how this thing is going to work. Under Windows, every partition is assigned a drive letter. For example, C, D, and E. These drive letters, or these partitions, are the top level root. You can't go a level higher than C. You can't go a level higher than D. Same thing for E. These are the top level root. You can branch under C, create directories, copy files, etc. Same thing for D, same thing for E, but you can't go a level higher than that. This is it. This is the top level root here, here, and here. So what's happening under Windows is that we're divvying up the physical disk into partitions. This partition is assigned to C, this partition is assigned to D, this partition is assigned to E. Under Linux Unix, it's different. Under Linux Unix, there's only one top level root, which is root. Everything else is mounted or is attached in a directory under it. So let's say you wanted to create a boot partition. You would create a directory called boot, and then you would mount it to that directory. You would mount the partition to that directory. To give you an example about how this works, under Windows, when the operating system comes up, all the devices are assigned drive letters. The partitions, the floppy disk is drive A, the CD-ROM, I don't know, maybe drive Z, etc., etc. The operating system comes up, go to My Computer, you can double click on them, you can start using them immediately. Under Linux, it's different. You put in the CD-ROM, bring up the operating system, it's not going to see it. You have to tell the operating system, and you have to attach that CD-ROM to a directory before you can access it. Once you mount it, which mounting and attaching is basically the same concept, mounting is just a fancy word for attaching. Once you attach the physical device, let's say the CD-ROM, to a directory, then you can use it to copy files back and forth. Now once you mount or once you attach a device in Linux and Unix, can you go a level higher? Or is it like Windows? No, the answer is you can go a level higher. You can always go a level higher until you get to root. But there's nothing on top of root. Root is the top level. So with Linux and Unix, you create a single file system hierarchy. So again, partitions under Linux and Unix are mounted to directories, like C, D, and E would be mounted to directories under root. See? Now that wasn't too complicated, now was it? We're getting closer. A few more slides, I promise, and then we're going to get into the installation of ESX Server. We're going to have some fun. Let's now talk about partitioning the disk. Now I'm going to ask you guys a few questions. How many primary partitions can you have on a disk? Anyone? Anyone? Bueller? Bueller? Did I hear somebody say 6? Well, you're wrong. 4? Yes. You can have 4 primary partitions on a disk. So now let's bring up that slide and take a look here. So can we have more than 4 primary partitions? The answer is obviously no, we cannot. So what do you do in the event that you need more than 4 partitions? Well, you have to delete one or not use 4 primary, use 3 primary and an extended partition. So why is this wrong, or why is this not recommended that you have 4 partitions? Let's assume you have a 10 gig hard drive. 10 gig. And you want 2 gig partitions. If you have 4 primary, 4 times 2, that's 8 gig. So what do you do with the 2 gig that are remaining? This becomes unusable disk space at this point because you cannot extend the disk anymore. You have 4 primary partitions. So the right way of doing it, and the optimal and recommended way, is to have 3 primary partitions and then to have 1 extended partition. Now in an extended drive or an extended partition, you can have logical drives, multiple logical drives. So I'm going to ask you, how many logical drives can you have in an extended partition? Anyone? Anyone? You can have 63 logical drives on an IDE, and you can have 15 on a SCSI. So IDE disks can have up to 63 logical partitions or drives, and then SCSI disks can have up to 15. So you see, you have better control of your disk space, and you have better management, and you have the ability to have more logical drives with an extended partition. And as such, the correct and recommended method is to have 3 primary and 1 extended partition. Now I'm going into all of these details about partitioning because in the coming steps, when we're going to install ESX, you're going to notice that we're going to have to partition the disk accordingly, and we're going to need several partitions. Now had we not gone through this and somebody had partitioned the disk with just 4 primary, he would have got into a problem because he couldn't have installed ESX Server with just 4 primary partitions. Now back to our presentation here. Now as you're going to see in a few seconds here, when we get started with the installation, the wizard is going to ask us to partition the drive. It's going to give us some recommendations, but it's also going to allow us to customize it if we want. Now before we can customize it, we got to understand what each of those partitions is for. Now the /boot is where all the ESX Server files are going to be installed in. The root is for the Service Console operating system. All the Red Hat stuff is going to be installed there. Now the swap is where you can allocate enough disk space for however much memory you're going to allocate. Now keep in mind here though, the memory that we're talking about is not the physical memory that's installed in the server's hardware. This is the memory allocated to the Service Console. Now the Service Console is allocated 300 to 358 meg by default, and this all depends on the amount of physical memory that's in the ESX host, that will dictate what the service console memory is set to. However, regardless of what it's set to by default, the first thing we're going to do post install is we're going to change the service console memory from whatever the default value is up to the maximum, which is 800 meg. So by default, our default swap file is going to automatically become 1600 meg, because we're going to double what the service console memory is allocated, which is going to be 800 meg. However, by default, you'll notice that it's allocated 600 to 718. Again, it's double what the default memory is going to be. So if the default memory was 300, then it's automatically going to have a size of 600. If it's 358, then it's going to have 718. Now, var log is where all the logs are going to be stored, any kind of patch management, etc., etc. That's where it's going to be stored. The VMK core partition is where ESX is going to write its dump file. So in the event that it halts, the system halts, or dumps, or crashes, or whatever, it is going to write the dump files to the VMK core. Now, VMFS3, typically this is the partition that you're going to allocate the remainder of the disk space to. VMFS is, of course, where all your VMs, your ISOs, your templates, everything's going to live there. Now, when partitioning, you got to get familiar a little bit with the types of file system that's going to go on every partition. Now, the /boot is going to get an ext3, which is the default file system for Red Hat Linux. The root is also going to get the same thing, ext3. Now, the partition dedicated for VMFS3 is obviously going to be a VMFS. The size is going to vary because it's going to depend on how much remaining free disk you're going to have, and you're going to allocate everything to it. Swap partition is going to have a swap, and then you have the var logs, again going to be ext3, and the VMK core is VMK core. Now, if we move on here and take a look at the default sizes and the recommended sizes for these partitions, you're going to notice that the boot default size is going to be 100 meg. We're recommending 200 meg. The root's going to be 5 gig. We're recommending 25 gig. You want to give it a little more room. You don't want the root to fill up. The VMFS3 is going to vary. Typically, after you've allocated space to all your partitions, whatever's left is VMFS3. Now, swap is 600 to 718 by default. Again, it depends on how much memory there is in the actual physical ESX host, but we're going to give it the maximum of 1600 automatically because we're increasing the service console's memory as soon as we go into post-install configuration to 800 meg, so we double that to 1600 meg. The var and var log is going to be 2 gig by default. We're going to give it 12 gig, and then the VMK core is 100 meg, and we're going to leave it at 100 meg. Now, this comparison chart here allows us an easy way to compare the different features that you get with the different editions of vSphere 4. So they've changed things around. They've now added the Enterprise Plus edition, which you have all the way to the right, and the Enterprise Plus edition has numerous features that are not available with the Enterprise, for example. And you'll notice if you want a distributed switch, or the Cisco Nexus 1000V, or the host profiles, or the multi-pathing APIs, then you would need the Enterprise Plus version to be able to do that. And then you have the Enterprise version that takes you all the way up to DRS, DPM. You can do storage vMotion, vShield zones. So you have some newer features there. And you can see circled in blue some of the new features that you have with vSphere 4. So for example, you get vShield zones, you get data recovery, you got fault tolerance, you got hot add, you have thin provisioning. All of those are new features that were introduced with vSphere 4 that are available with the Enterprise version, but then you have on the right the Enterprise Plus version that gives you additional features. And then if you move down to, the more you move to the left, the less features you get with a different version. So with the Advanced, you'll go up all the way to vShield zone, so you'll lose storage vMotion and DRS. And then you have the standard version, which takes you all the way up to high availability and thin provisioning. So this kind of gives you an overview. That way you can make a more informative decision when it comes time to purchase your vSphere edition as to which one suits your environment. You might be buying a vSphere and you don't want to use some of the Enterprise class features, so you probably don't want to go with more than the Advanced edition, for example. So there's 3 ways of installing or deploying ESX. There's the default way, which is the graphical mode, which is what we're going to be using. There's the text mode, and then there's the scripted mode. Now, the text mode is typically used if you're going to be installing ESX over a WAN link or over slow links, thereby getting rid of all the graphics, making the screen not have to refresh, not having to send a lot of packets across that WAN link, rendering your connection slow. Using the text mode, everything is text-based. Your installation goes smoother, it goes faster. The scripted install is pretty cool because it allows you to have a standardized way of installing ESX, whether it's for one server or if it's for 10 servers. Now, in order to install ESX, we're going to need console access to the server. Now, whether that means you're going to be hooking up a monitor directly to that server, or whether you're going to be using a remote KVM such as the Avicent or the Raritan, or if you're using HP's ILO 2 or Dell's DRAC. And we're probably going to be using a mixture of both the HP ILO 2 and Dell's DRAC for different functions throughout the video. But for the purposes of this installation, we're going to start off with HP's ILO. I'm going to remotely connect to a server, so let's get right to that. The ESX 4.0 splash screen gives you several options of installing ESX. The first one is graphical mode. That's the default. Typically when this splash screen shows up, it's going to give you about 30 seconds to make your selection, and if you don't make a selection, it'll automatically default to the graphical mode. The second mode on this screen is a text mode. A text mode is a less graphic intensive installation that is typically used if you're installing over the WAN over a slow link. This would be good because you don't have all that graphical stuff that takes up all that bandwidth. Now there's also several scripted installs, and we're going to do a scripted install on screen later on in this module, but for the purposes of this exercise, what we're going to do is we're going to go through the default graphical mode. So I'm just going to go ahead and click enter to kickstart this. It's going to start loading. I'm going to pause the video to allow this to finish a little quicker. And we're going into the graphical mode now. It's initializing the scheduler here. It's going to start some services. Now, since we're going through ILO, you guys are going to have to bear with me a little bit. The mouse synchronization isn't going to be perfect, so sometimes it's going to be hard to get the mouse to the next button. So we're going to try here to get past the welcome screen. We're going to accept the license agreement. You guys can feel free to read it. It's just a standard license agreement that you see with any type of software. If I can get the mouse to select it, that'd be nice. And we're going to click on next to get past the screen as well. We're going to select English for our language. Now, if there's any type of custom drivers for any kind of device that you need to load, this would be the screen where you would load them at. This kind of reminds me a little bit of the Windows setups, when during setup it would prompt you for any kind of devices and you would hit F3 to load the devices. This is kind of a similar situation where if you have any kind of custom drivers that ESX obviously supports, this would be the time to load them. Now, for the purposes of this example, we're just going to keep it at no, and we're going to click next to continue. Now here you're prompted, basically it's telling you that past this point, if you click yes for it to start loading the system drivers, which are drivers that it needs to load to get the installation going, but after it loads the system drivers, then you don't have the ability to load any kind of custom drivers. So for us, we're just going to click on yes, so to allow it to load the system drivers, and there it goes. Once it's done, we're going to click on next. Now here, if you have a serial number specific to this installation of ESX, you can feel free to load the license in here. But for those of you that intend on using Virtual Center to handle the licenses, you can select the second option, which is to enter a serial number later, and we'll just point ESX to a Virtual Center license server. For the purposes of this example, again, I'm just going to point it to enter serial number later and keep going with this screen. Next. Now on this screen, it gives you the ability to select the NIC card, or the network interface card, that's going to be associated with the service console. You have a drop down. Now from this drop down, I haven't added any more physical NICs, so all I have is one for the purposes of the example. But if you had more than one, then you would select the appropriate one that you have connected for the service console. And if you need to add any type of VLAN ID to it, this would be a good place or a good time to check the box and add the VLAN ID that's relevant. We're going to keep that off for now, and we're just going to click next, accepting the defaults. I would always recommend that you give or you configure your TCP/IP stack accordingly and not rely on DHCP to assign an address to your ESX hosts. So we're going to also assign configure the entire TCP/IP stack here. And after configuring the entire TCP/IP stack based on your settings, we're going to click on next to continue. At this point, you have the standard type setup, which is kind of an express setup that skips over some of the more advanced features, such as configuring how you want your disk to be laid out and how you want the different partitions on the disk to be sized. So if you go with standard, it's just going to skip over that step and just accept all the defaults. But just so we show you what's involved, we're going to go ahead and click on the advanced setup here and go through that step as well. Again, if you're unsure of the advanced options, I would go with standard. The checkbox down here that says configure bootloader automatically, if you're unsure of how to configure that during the advanced setup, keep that checked and continue. For the purposes of this example, we're going to keep that checked and we're going to move forward with the installation by clicking on next. And now it's prompting me, since I have it notices that I have 2 hard drives on this server. So it's asking me where I want to install it. I'm just going to select the first one. This is basically a warning message telling me that all data on the selected drive is going to be wiped out because it's about to initialize it. I understand that, so we're going to go ahead and click OK. Now it's asking me if I want to create a data store, a local storage data store on the ESX host, and it's prompting me for a name for that data store. I'm going to keep the name as the default storage one, and I'm going to let it create a data store on my ESX box. And this is where you would configure the different partitions on your ESX host. Now remember, during the lecture we went into details on the sizes of the partitions and why you need to create certain partitions and why you need to size them accordingly. This is where you would come to put that plan in effect. This is where you would come to modify it or to even initialize it or design it. You can click on New, which allows you to add more partitions or mount points, and you can select the size, etc. And if there are any existing mount points, obviously you can select them, and then you can click on Edit to modify any of the settings. For the purposes of this example, we're just going to keep everything at the defaults. Feel free to modify this or change the layout of the partitions on your disk accordingly. Now since I'm in Central Time Zone, I'm just going to go ahead and change it. There it is, America's Chicago, and I'm going to click on Next after selecting the time zone. Now you can select the time, date, and the month, whatever you need to, or you can point it to automatically synchronize with an NTP server. If you have an NTP server locally, this would be a good time to point it to your NTP server. If you don't, or if you don't know it at the point or at the time of installation, you can always configure the NTP server at a later time, and I'll show you how to do that. For the purposes of this example, I'm going to keep it at manual for now, and the date and time is off, but I'm going to keep it the same way for now, and we'll synchronize it with an NTP server at a later time. Now as far as the root password is concerned, you obviously have to enter a root password that is at least 6 characters long. Now what you can do here is you can create additional user accounts that allows you to connect to this ESX server. So if you needed to create that, this would be a good time. Now keep in mind, direct root access is going to be disabled once the ESX server comes back up. So this would be a good time to create a user account that allows you to do a switch user at a later time so you can log back in as root. For now, I'm just going to keep this at the default. You can read through the summary, and once you're comfortable with the settings, click Next to start the installation. And that's it. Installation will begin and we'll finish shortly. Alright, the installation took a little bit of time, but it's done. So we're going to go ahead and click on Next here to finalize it and finish, which is going to give it a reboot. And we should come back up with ESX4, folks. That's all there is to the install. It's a very straightforward installation. Not much there. But when it comes back up and you've installed Virtual Center, that's where the real work starts. And here's the server booting, running all the necessary services and starting them up. And there it is. The server's up. Now you can control it, you can configure it, and you can do all sorts of good stuff with your ESX box at this point. Alright, after the installation of ESX, now we can browse to the IP address that you guys see on screen here. So what I'm going to do is I'm going to go to a web browser. And let's go ahead and open this up, and we're going to browse to 192.168.1.12, and voila, you get to a screen like this. This allows you to download the vSphere client from here. So if you click on download the vSphere client, it's going to allow you to run it and install it. Now considering that I've installed this on my system, I'm going to skip this step, and at this point let's go ahead and log in to the vSphere client. Once installed, I'm going to double click on the vSphere client to log in. I'm going to put the IP address of the ESX host, and we're going to log in with root and the password we chose during the installation of ESX. I'm going to ignore the SSL certificate, And voila, welcome to ESX4. Now we're getting an error here, or not an error, an information screen saying that this is an evaluation license. I haven't added any licenses, so we're going to click on OK to accept it. And this is your home screen. Once we log into Virtual Center, install Virtual Center, you'll notice that there are more icons, but this is the first screen you see when you install ESX4. Now to get to a more familiar screen, for those of you that have seen ESX3 and so on, you can click on the inventory and you'll get to a more familiar screen. From the summary tab here, you'll be able to take a look at what type of hardware this is installed on and a brief summary of the system. But for the most part, and throughout this training course, you guys are going to practically be living inside the configuration tab. Now when you click on the configuration tab, it's going to default to the health status, so you're going to be able to see the health of your hardware, etc., etc. For the purposes of this example, the first thing we want to do is we want to modify the memory of the service console. And to do that, I'm going to click on memory. You'll notice here that, as I said during the lecture, the memory will default to either 300 or 358. Sometimes it'll go up or down. It depends on how much memory you have in the ESX host. That'll determine what it defaults to. In my case, it's defaulting to 300 meg. Now in order to change that, we're going to click on properties up here, and we are going to up that to the maximum, which is 800. Now for these changes to take effect, the system has to be rebooted. So I'm going to click on OK. It won't reboot now, but it just lets you know that this won't take effect until the system actually restarts, and you'll notice here that it says 800 meg on restart. Now the second thing we want to do is we're going to enable an NTP client in order to synchronize the time of this ESX host with an NTP client or with an NTP host that you might have somewhere on the network. And to do that, you have to enable the NTP client. You can do all of that from within time and configuration here. And you'll notice that the NTP client on this host is stopped. So what we're going to do is we're going to click on properties. The first thing we want to do is we want to enable NTP client. And you'll notice that all of my time here is messed up. So I'm going to go ahead and go into options. Once you're inside options, it gives you the status of the NTP client. It's currently stopped. You can start it automatically if any ports are open, and stop when ports are closed, etc. Start and stop with host. You can start and stop the NTP client with the host, and then you can start and stop it manually. I'm going to leave it at the default for now. You can go ahead and click on, you can always start it and stop it manually, but I'm going to go ahead and click on NTP settings here. And this is where it gives you the option of adding an NTP host. Let me bring this within perspective. So you'll be able to put in the IP address of the NTP server that you want to synchronize with. Now, I'm sure you guys have guessed I don't have an NTP host configured, so I'm not going to put anything, but this is where you would go to do that. You can click on OK in your case, and then just make sure you restart the NTP service in order for these changes to take effect. So if we click on OK here, and then we go ahead and click on OK, even though I don't have an NTP host, what you'll notice is that the NTP client is now running. So this is how you would configure your NTP. Now let's go ahead and minimize our vSphere client and try something. Now there are two ways of logging into ESX. A lot of times users are going to want to log in or SSH in, secure shell into the actual console of ESX. Now by default that's disabled if you're trying to use root. So I'm going to give you an example. Let's go ahead and launch PuTTY here. And we're going to put in the IP address of the server that we're working on at this time. I'm going to accept the certificate here. Let's bring this in perspective. I'm going to log in as root, and I'm going to put in the password that I set up during the install of ESX. Now it's going to give me access denied because by default root isn't allowed to log in via SSH. And there it is. So there are two ways of doing this, and we're going to go through both scenarios. Now the right way and security best practice will dictate that you create a generic user account and then use that user account to log in via secure shell and do a switch user, which is a Linux command that allows you to switch the current user to the root user. And that's the best practice from a security standpoint. Now I know that a lot of you are going to want to bypass this step and log in as root directly. While I don't recommend it, I'm going to demonstrate how you can do that. So let's go back into, let's go ahead and close this and go back into our vSphere client. Now since we're logged into vSphere to the ESX host, it allows us to add users to this host directly. So what I'm going to do in this case is click on users and groups, and you'll notice these are all the users that are part of the service console. So these are Linux users at this point. I am allowed to add a user from a graphical user interface here. So if I right click anywhere, click on add, I have the option of adding a user. What I'm going to do is I'm going to create Eli, username Eli, and let's go ahead and give Eli a password. And now you'll notice the checkbox here to grant shell access to this user, which means allow this user to log in via SSH, but don't give him anything else. So we're not going to give him any kind of permissions. We're just going to use this user as our gateway into the ESX host via secure shell. So I'm going to click on OK to add the user, and voila, you notice this user has been added. So let's try the PuTTY again. Double click on it. We're going to log in as Eli this time with the password that we just created, and would you take a look at that. Now, how do I go to root? So it's easy. To change to root, you're going to use the command su, which stands for switch user, space dash. Dash means give me God control, give me everything. So I'm going to click on enter, and now it's prompting you to enter the root password, and voila. Would you take a look at that? Now, once we're logged in as root, now we can change the default policy that controls whether or not root has access directly to connect via SSH. Again, I know some of you are going to want to bypass this, so let's go ahead and enable SSH root access. Alright, so what we're going to do is we're going to use an editor to modify a file within the service console that allows root access. And to use that editor, we're going to use the editor that's known as VI. We're going to do space, we're going to do etc sshd underscore config. This is the file that holds the permissions to allow or deny access to root. We're going to click on enter. And then we're going to scroll down here to where it says, let's drag this a little bit, make it a little bigger, to where it says permit root login. And you'll notice in my case, permit root login is set to no. So what I'm going to do is I'm going to change that to yes. We're going to hit the escape key to exit the editor, and then we're going to do :WQ, which stands for write Q, which means save the changes. So once it saves and quits, we are going to need to restart the SSHD service. So what I'm going to do is type in service. Whoops, if I can type it would be nice. SSHD space restart, and voila. Now let's try to exit out of here and launch PuTTY again, log in directly as root. Double click, we're going to enter the IP address of the server one more time. We're going to log in directly this time as root, and voila, there you go. Now again, security best practice dictates that you use a generic user and then switch user, but from my perspective, I have to show you guys everything that you need to see, and I'm going to leave it up to your best judgment as to what you would need to use in your particular environment. Now, while we're in SSH, let's talk a little bit about NIC cards. Now, what if during the installation of ESX you chose the wrong physical NIC card? What do? Now there's a few options. Obviously, you either connect via ILO or remote KVM, log into the server through the remote console, try to change physical NIC to the right one, as I'm going to show you, or you can go into the back of the server and start unplugging all the NIC cards or all the NIC cables that you have and plugging it in each one to see which one is going to reply, and as such you're going to be able to connect to the server on its IP address. Regardless, this is a problem that we need to fix. So what we're going to do is we're going to type in the command esx cfg vswitch space -l. So let's do that. Now this will bring up the existing service console configuration so we can review it. Alright, so how can we read this? Basically what we can see here is that the service console is locked to VM NIC 0. Now if this is the right NIC, cool, everything's fine and dandy. But if this is not the right NIC and you want to find the right NIC, then what you do is you need to issue a command esx cfg -nic with an S space L for list, and voila, it's going to give you a list of all the physical NIC cards that are available on the CSX host. Now again, what are we looking for here? We are looking for the lowest PCI address possible. And as you can see, this is the lowest PCI address that you can find from within this list. So this is the correct NIC to associate with your service console if you wanted the first NIC on your host to be the one associated with the service console. Now as you can see, this is VM NIC 0, which is the right one. However, if this was not the right one, the command to issue in order for you to unlock the service console from being associated with VM NIC 0 and lock it to another VM NIC is the following: ESX CFG-vSwitch space dash capital U for unlock. Now keep in mind, capitalization matters. This is Linux. Space VM NIC 0 space vSwitch 0. Now VM NIC 0 is basically we're telling it to unlock VM NIC 0 from Virtual Switch 0. You're going to ask, where did I get Virtual Switch 0? Back up here when we were looking at the configuration, Virtual Switch 0 is associated with Virtual or VM NIC 0, which is the actual hardware NIC card that's associated with it. Now after you run this command, it's going to unlock it, and the way to lock it to another hardware NIC is you simply change the -U to a -L and make sure the L is capitalized, L for lock, and then you select the NIC card that you want. Now VM NIC and then the number of the NIC that you want. So here you have several options to choose from this list. You can associate it with VM NIC 4, 5, 3, 2, whatever you need, and then Virtual Switch 0 is the default for the service console that you want to associate it with. Installing and configuring ESXi. Now throughout the course of this video, we've been talking about ESXi and the differences between that and ESX server, but I wanted to create a module that focuses on ESXi, that groups all the features and functionalities of ESXi, simply to emphasize the importance and to stress that VMware is taking ESX server in general towards a lighter, a thinner hypervisor, and the future, and you can bet on that, is ESXi. Now obviously VMware is not going to quickly release or stop supporting ESX server, but it's going to phase it out. So it's slowly going to go towards a hypervisor that has no service console, a hypervisor that's completely relying on Virtual Center in order to manage it, and that's going to be the future. It's going to be a lighter, it's going to be a thinner hypervisor. So let's quickly take a look at some of the differences between ESX and ESXi. With ESX, you're going to notice that the main management functionality is going to happen through the service console operating system. Whereas with ESXi, we don't have a service console. The management happens either through Virtual Center or through command line, remote command line interface, which can be installed on a Windows or Linux machine. It's just an application that provides remote command line to the ESX host, or you can do that by downloading a virtual machine. It's an appliance that you can import into your ESX server and use that to issue remote command lines to your ESX host. Now what's the advantage of not having a service console? The advantage of not having a service console is now you've eliminated another layer of security. So with ESX server, a lot of people can argue that you have a vulnerability here. You have a layer that you're providing for outsiders, for hackers, for people that want to harm your systems in any way to attack the surface. By using ESXi, you've just eliminated your attack surface by completely removing the service console. You're removing an operating system. So whatever vulnerabilities exist within the service console operating system, with ESXi, you've just eliminated those. With ESX3, the server, a lot of my clients, when I visited them, the first thing they'd ask me, we want to put an antivirus agent within the service console. Obviously, I'd recommend against it. I would not recommend to put an antivirus on the service console. But the second thing that they're gonna come to you, would you bet your career on it? Now, this poses a dilemma because yes, as long as an operating system exists, there is a possibility of somebody writing a virus that could target a vulnerability within the service console. So at that point, you have a dilemma here. Should you install an antivirus or should you not install it? Well, with ESXi, we make it easy. Well, there's no service console, so there's no need for you to install antivirus or spyware or adware or any anti that you might want to add to protect your server. It simply does not exist. Now, this next slide here will show you the difference as far as the architecture between ESX, which is here on the right, and ESXi, and you'll notice that again there is no more service console. So if we move forward with this presentation, let's take a look at the different versions that you have with ESXi. So you have ESXi installable, which basically means that you can download the media from VMware and you have a server and you can install ESXi on that server. Now ESXi has a very small footprint. It's a 32 meg footprint, so you can see how quickly you can install or deploy ESXi installable on a server that's going to meet your minimum hardware requirements. Now the second version, if I might call it, of ESXi is an embedded version. So a lot of these hardware manufacturers, what they're doing now is they're embedding ESXi either on a USB that you can connect at the back of the server, or on a chip that's burned directly on the motherboard. So what you have in that case is you bring in your server from HP, from Dell, from IBM, from whoever you buy your servers from, you unpack it, you rack it, you power it on, and voila, ESXi just powered on. All you have to do is configure it, add it to Virtual Center, and you're done. Now I know a lot of you are just eager to jump in to ESXi and start installing it. So what we're going to do is we've already downloaded ESXi from VMware. We're going to log in through ILO and we're going to install ESXi and configure it. So let's get right to that. Alright, so now we're going to do an install of ESXi. Now you're going to notice that ESXi's install is going to be very quick. You're not going to have that many options to configure. Again, ESXi is meant to be an extremely thin layer of software. So it's about 32 meg in size. The installation is going to go very quickly, and that's the whole point. Now there's two ways of getting ESXi, either installing it or you can have it embedded on some kind of a chip or some other way that comes with the server. So it's very simple. The flash screen gives you pretty much two options. We're going to go ahead and use the ESXi installer to get started. There you go. It's initializing the scheduler, the setup. A few more minutes and this setup will be complete. And again, we're going to accept the license agreement here. We're going to select the disk where we want this to install on. And we're going to confirm that disk by pressing enter. And we're going to confirm it again. It requires 3 confirms. And there you go. So you notice it took the most time to actually load the ISO image. Now keep in mind I'm doing all of this over ILO. So ILO tends to be a little slower than if you were to do it over like a regular CD-based install. But as soon as it loaded all the necessary drivers and information it needs to install the software, the installation of ESXi is just a snap. And voila! It literally took less than 5 minutes to install ESXi. Now what I'm going to do is I'm going to actually disable my virtual media drive. And I'm going to do that over, here. I'm going to disconnect it. And then we're going to press enter to reboot this box into ESXi. And here it is coming back up. I love ESXi. ESXi installs first and asks questions later. So during the install process, you actually don't need to give it an IP address or give it a name or give it anything like that. It's going to install everything first. It just needs some of the basic details like what hard drive do I install on, etc. And then it installs the software. When it comes up, it allows you to configure it, which is great. And voila, it came up, and as you'll notice here, there's no IP address that's configured. It's just giving you basic information. The only thing you can do from this screen is hit F12 if you want it to shut down or restart this computer, or F2 if you want it to go in and customize the system, which is exactly what we want to do. Once you're in here, you can configure the password. Obviously, this would be the root password, and then you can configure this machine to be in lockdown mode. So when it is in lockdown mode, it prevents anyone from using the root account to access this server from anywhere on the network. Now we move on to configure the management network, and here's where you can give it a host name. And let's go ahead and go in here. You can create, you can select your network adapters from here, and then you can use escape to go back to the other screen. You can give it a VLAN if you need to. You can configure your IP stack. So this is where you would come in and either give it a configuration for a static IP or a dynamic IP using DHCP, IP version 6 configuration, DNS, custom DNS, etc., etc. If you need to restart the management network, which is something you tend to do many times with ESX, using a command line with ESX, the full install through the service console, through ESXi, you can come and do that via the GUI, so there's no command line necessary here. If you come to test management network, you're able, it's going to perform a quick test by pinging several things on the network. Really cool, really useful if you need to test connectivity. You can disable the management network if you need to. You can configure your keyboard. If we can go in here, you'll have several options on the keyboard layout that you want to configure. The rest of these options are self-explanatory. You can view the support information, view the system logs, you can restart the management agents, you can reset the system configuration back to the defaults, remove custom extensions, etc., etc. And that's all there is to ESXi. Again, that's why I love ESXi. It's so thin, it's very straight to the point. There's nothing to configure along the way. Install it first, ask questions later, configure it later. You bring up the system in a snap and you install it and you're up and running very quickly. And again, with ESXi, you remove the service console, you remove that layer or that attack surface that was available with the service console and having to worry about it. It's just a thin layer. All it does, all its purpose in life is to be a hypervisor and to allow for several virtual machines to run on the hardware. And that's a wrap for this module, folks. We hope it's been informative for you, and we'd like to thank you for viewing.